Okay, today what I am going to be doing is I am going to explain one problem of motion of charge. Now, if you remember in the last video, I explained everything about motion of charge, how they interact to each other, and everything that you're supposed to know before you can work with this type of problems. Now, for the classwork, what I need you to do is you are going to copy in your notebook this problem that I am explaining right now, and you're going to upload a picture of the example. I'm going to give you another example, but for the second example, it's only for you. You can check and see everything, but you don't need to do it in your notebook or upload the picture of the second problem in Google Classroom. Now, let's start with the first problem. Now, in the first problem right here, what we have is we have two objects. Now, the first object, object A, that is the square, the box. And then for object B is the circle. Now, object A, as we see right here, we need to, now with both of them, we need to answer the question A, B, C, D, and E. Now, question A is about the charge of the object. We want to know what is the charge in object A. See right here. We want the charge in object A. Now, we need to count, we need to find the quantity of positive and negative. Now, if we see right here, we have in problem in object A, one negative and two negative. That means right here, you're supposed to write two negative. And then we go for the positive. We have one positive, two positive, three positive, and that's why we have right here three positive. That means for the homework, what you need to do is you're going to count the quantity of positive and negative, and then you're going to write below the quantity. Now, for object B, that is the circle, right here, what you need to do with the circle is exactly the same. We are going to count the charge for object B. Now, for object B, we have only one positive, and that's why I wrote right here one positive. And for negative, I have one negative, two negative, and we have the answer right here, that is two negative. Okay? That means for object A, we have three positive and two negative. And for object B, we have one positive and two negative. And this is the most important part because the data of the positive and negative is what is going to help you to do every single step. Now, let's go for part B. In part B, we want the total charge of the object. And then right here, exactly like what I explained in the previous video, we are going to add the positive and the negative. Now, if we see right here, we have three positive and we have two negative, and we are going to add them. And 3 add by negative 2, because remember we have two negative, we need to write here that is negative. The answer is equal to positive 1. That means that the charge of the object A is going to be equal to positive 1. Now, let's go for the object B. Now, for object B, we have one positive right here, and we have, let me go right here, two negative. And we're going to add them. 1 plus negative 2 is going to give me negative 1. That means that the object B, or the circle, the charge is equal to negative 1. And right here we have part B, where the charge of object A is positive 1, and the charge of object B is -1. Let me erase this right here. And let's go to the next part. What we need to remember is the charge. Charge of object A is +1, charge of object B is -1. Now let's go for net charge. And net charge means the charge of both objects when you add them and we want them together. And see right here. We have that the net charge or the total charge is the charge of object A and the charge of object B, and we are going to add them. Now, if we see right here in object A, we have that the charge is +1, and object B, we have that the charge is equal to -1. And when we add +1 and -1, this is going to be equal to what? 0. That means the total charge of both objects or the net charge is equal to 0. And what we have right here, charge A is equal to +1, charge B is equal to -1, but the charge of both objects together is equal to what? 0. And this is the most important part right here in this problem. Now, using this data that we have of the charge of every single object, now we're supposed to be able to answer part D. And part D, the question is, what is the interaction between the object? Let's see right here. What is the interaction between the object? Now, you need to remember the video when I explain what happens when one object is positive or negative and positive, or if they have the same charge. Now, the interaction between these two objects, there is going to be attraction. They're going to attract each other. And why this is going to happen? Since they have what? Different charge. How are I going to say they have different charge? Since one is positive and the other one is negative. When we have one that is positive and the other one that is negative, they are going to attract each other. They want to be together. And this is what we need to remember right here. Now, remember, if both of them are positive and positive or negative and negative, they are going to repel each other. Since they are the same, and the same, they don't want to be together, okay? Let's go to part E. And part E is exactly the same like part A, B, C, and D, but then here is going to be together and with something else. Now, part E say, if object A acquire one negative charge from object B, and then the key right here is from object B, remember, the charge are moving from one object to the other object. This is not magic that came from the, I don't know, the sky or something like that. It came from object B. Now, see right here the sketch that I draw when we have object A and object B. Now, this charge that we have right here in object B is going to move to object A. And this is the second video that we have, the second sketch, yeah? That is the part that is after, okay? Now, when the charge move from object B to object A, now we have 1, 2, 3 negative charge. When before we had only what? 2. But right here, before, in the circle, we had 1 and 2 negative charge, but now we only have what? 1, since this second charge moved from the object B to the object A. Now, let's go to do the same that we did before. Find the charge of object A and find the charge of object B. This have error, guys. This doesn't supposed to be low, supposed to be charged, okay? It sounds the same, but it's not the same. Okay, it's charged. Let me write this right here, and then we can continue. Now, let's go. Charge area final is this one. We're going to look right here in the after. We have 1, 2, 3 negative. That is right here. And we have 1, 2, 3 positive. That is right here. That's mean for the object A, we have 3 negative and 3 positive. Okay? Now, for object B, we have 1 positive and also 1 what? Negative. And that's why we have here 1 positive and 1 negative. Hey, and don't worry, because this sample that you have right here, I am going to send you this sample in a PDF and doesn't have this error that you can see right here in this problem. Now, object B, that is the circle that I am coloring right now, have 1 positive and 1 negative. 1 positive and 1 negative. Now, let's find the total charge of object A and object B. This right here. Now, for object A, we have 3 positive and 3 what? Negative. And when we add them, positive 3 and negative 3 is going to give me what? 0. That means that the charge for object A is going to be equal to 0. Now, let's go for object B. In object B, we have 1 positive and 1 negative, and that's why we have here 1 positive and 1 negative, and when we add them, it's equal to what? 0 2. That means that the charge also for the object B is also what? 0. Okay? Now, let's go right here. Now, we want what is the net charge or the charge of both objects when we put them together. Now, see right here. For the total charge, what we're going to do is we're going to add the charge of A and the charge of B, but now it's easy because the charge of A is equal to 0 and the charge of B is also equal to 0. And 0 always going to be equal to what? 0. That means the total charge or the net charge, that is how you're supposed to explain this problem, is going to be equal to 0. Okay, that means the charge that we have right here is equal to 0. And something that you need to try to understand or to analyze is that the net charge of object A and B after the motion of the negative charge is equal to 0. But if we go at the beginning of the first problem, also the net charge is equal to what? 0. See right here. Before the motion and after the motion of the negative charge, the net charge of both objects is equal to 0. And guys, and this is what? Conservation. Why? Because one charge moves from one object to the other object. Does mean that if something increase, something needs to decrease. And then right here, the net charge before and after always need to be the same if we are trying to analyze the motion of charges of both objects and both are in the same system. Both are together. Okay? Now, let's go to the last question. Here is, what is the interaction between the objects? And then here is going to be no interaction. And why there is going to be no interaction? Because both of them are what? Neutral. The charge, the net charge in both objects is equal to 0. That means they are not going to interact to each other. Unless, you know that, in about like 2 or 3 videos period this one, if we rub one object with the other object, yeah, we can create motion of charge and they maybe have an attraction or repulsion force. Now, what I need you to do is you guys are going to write this sample in your notebook, and then you're going to upload a picture in Google Classroom. Now, if you see right here, I have a second example that is similar to the sample I explained right now, and this example is going to be in your Google Classroom.